All right, it's lecture 3, shaping processes for plastics. We're studying. In the last class, we have been also studying the shaping process. It's the part 2 of the shaping process. We'll start with extrusion. It's a blown film extrusion process. That means the plastic rolls that we see in the market, how those plastic rolls are made. We're going to study that. In this case, I think it's better to show you the video first, and then you can discuss about it. Okay, that's enough. So this is the blown film extrusion process. The extruder is same as we have seen before. It's the same screw type extrusion. It's a continuous process. It's kind of the extrusion process which produces the pipes actually. The similar way it works. The only difference is that in this case we expand the inner diameter of the tube with the help of air. Okay. With the help of air in, we actually expand the tube that comes out from the extrusion chamber, the extrusion unit, and then we use the air pressure, continuous air pressure inside, so that the tube gets expanded, and there are some guide rolls are provided to keep it in place actually, and the cold air is sprayed here, cold air. For the cooling purpose, and it becomes solidified in this region. After the frost line, actually, the plastic becomes solidified, and then these guide rolls, collapsing rolls, actually put them together, and then this squeezing pinch roll actually act as a barrier for the air, so that air doesn't go out this way, and also you make the plastic sheets in here. Okay, and then that sheet comes out, and then you goes to the window reel, where you make the plastic reels. And the thing is that if you want to control the thickness and or the diameter, you can do that using the extrusion rate. At what rate the material is coming out from the extruder, and the air pressure. If you increase the air pressure, then the diameter will increase, and also that will affect the thickness of the material. If you want to control the thickness, that means the gauge, then you can do it with the help of air pressure. And thickness, larger the diameter, smaller the thickness will be. And also it will also depend on the extrusion rate. If the extrusion rate is high, then you will get higher thickness. Okay. If you want to compare it with the slit die extrusion that we have studied in the last lecture, slit die extrusion, the blown film method produces a stronger film. Actually, in this case, what happens is that due to the internal pressure, the material that is produced here, like the thin film, plastic film that is produced here, gets the isotropic property. Isotropic property. That means that if you want to consider a sheet, then the strength in this direction or strength in the vertical direction, or in a certain angle, the strength will be the same. But in the case of slit die extrusion, since the material is squeezed out of of a slit, it actually gets directional property. What happens is that if this is the slit and the plastic is coming out from the slit, then due to the compression in here, it occurs that it has got higher tensile strength in this direction, but in this direction it will have less tensile strength. Okay, this is higher and this is lower, so it does not get the isotropic property because of the squeezing in the slit die. But in this case, what happens is due to the air pressure, the tube actually expands uniformly, since the air pressure is uniform all over the area, all over this area. So the thickness that we get from this extrusion process, the thickness is not much controllable, but the expansion is uniform, and due to that the material gets isotropic property. Okay? And the thickness control and production rates are lower. Okay, the lower, but you can enhance in considering different different parameters like extrusion rate and the cooling system, or the length of the system. Okay, there are many other things to increase the production rates you can consider. Okay, do you have any question?
Sir, on which material the tube built in?
Sorry, on which material?
Tube, the tube.
The tube.
Which exposed on air pressure. Yes.
In here?
Yes, sir.
Actually, I did not understand your question.
Sir, tube and material ta ashole ki? Jeta hocche
Oh, material. It can be polypropylene, polyethylene. Okay, just like just like the polythene rolls we see in the hardware store. You know, those are made actually in this using this method. Okay.
Yes, sir.
Polyethylene, polypropylene are the main.
I have another question.
Okay.
Collapsing rolls আর pinch roller মানে দুইটার ওয়ার্কিং প্রিন্সিপাল আসলে ডিফারেন্স টা collapsing rolls আর pinch
difference is collapsing roll acts as actually what happens is that if you looked at the video, you'll see that there is a place where the function of the collapsing roll, you can see that these two rolls here, these two rolls actually act as a pinching roll. That means they actually these two, not these two, these two, they act as a pinching roll. They actually, it's a continuous cylindrical roll. If you want to squeeze it to make look like a sheet, then you are doing it using the pinching roll. Okay, and in here, actually the guide rolls that we are talking about, they actually stress in here. Oops, it's not working. Anyway.
Sir, video অনেক সময় প্রবলেম করে ভিডিও প্লে করতে
হ্যাং হয়ে গেছে।
স্যার এটা কেমন যে হচ্ছে একটা হচ্ছে জাস্ট শীটের মানে ফ্লোটা কন্ট্রোল করে।
Okay, do you have any other question? Then we'll move forward. Can you see the slide?
Yes, sir. Okay. You can move.
The next one, it's also extrusion. The name is calendering. Okay, it's like the similar. It's kind of 2 high roll or 3 high roll, something like we studied in the manufacturing process for metal forming. It's kind of similar to that. The rubbery thermoplastics, such as plasticized PVC, the PVC that is rubbery, we call it plasticized because some other ingredients called plasticizer is used with the PVC to make it rubbery or flexible. And in this case, what happens is that when the material comes out of the extrusion screw and falls in between two rollers, in between these two rollers, and then this two roller actually squeezes the material out, and then the rollers pass through the cooling rollers. These two rollers are actually cooler. Okay, they are cooled using either water or any other method for the cooling purpose. This roller actually cools in this surface, and this roller cools the other surface, and then it goes to the sheet stroke or in the reel. Okay, the production rate is very high due to the use of cooler roller, and also it's like 2.5 meter per second, and the good surface finish due to the squeezing action of these two rollers, and the subsequent cooling on top of the roller. Instead of cooling if we look at the blown film method, we see that the cooling is done like while the film is hanging in the air. Okay, and that's why the uniform thickness cannot be obtained. But in this case, since there is pressure acting, and the surface gets good finish as well as high gauge accuracy. And the application of these kind of products, it's mostly kind of sheets, they're like tablecloths or floor coverings that we use as mat, floor mat, shower curtains, which is strong and also thicker, kind of thicker, and pool liners, tablecloths, inflatable boats, toys. We can make a lot of things actually using these sheets. Further, because most of these cases, this calendering is used with the thermoplastic material. Once you produce a sheet, then you can use a die to make it, give it a certain shape. For example, if you want to make a bowl out of this, okay, then you keep the sheet, put it in here, something like that, and then you use a punch of the same diameter, like similar shape, and then heated punch. Actually, this punch has to be heated, and then you give them the shape, because you can reheat the thermoplastic and produce a new product out of these sheets. Okay. Okay. Do you have any question on calendering?
স্যার, আসসালামু আলাইকুম স্যার।
Yes, Abdullah.
স্যার আব্দুল্লাহ বলছিলাম স্যার, এখানে এই থিকনেসটা তাহলে ফিক্সড এই রোলারের সাথে সম্পর্কিত না? এটা
thickness depends on the spacing between these two rollers.
Yes sir, yes sir.
Okay.
Yes sir, okay.
The next one, extrusion, is fiber and filament production, or spinning, that we say in the jute industry. Actually, this spinning term is mostly used. The spinning mill, we used to say. The spinning is kind of making thread or making yarn. Okay, to make yarns, we do the spinning in the case of natural fiber jute. In this case, we are going to produce fiber and the filament of plastics. Okay. In the case of fiber, what is fiber? The definition, if we look at the definition, it says like, if the material whose length is at least 100 times its cross-sectional dimension. Okay, if the diameter of if the length is 100 times of the diameter of any strand, if it is T, diameter is T, then 100 times, then it we used to say it fiber. Sometimes we also the filaments, we also call the filaments as fiber. The filaments are actually the fiber of continuous length. We don't cut it, or it's not, there is no definite length, but it's a continuous filament that's wound in a reel. Okay. And there are three principal variations of spinning of synthetic fibers. Plastic fibers are synthetic fibers. So there is melt spinning, dry spinning, and wet spinning. We're going to study all three of these. First one is the melt spinning. In this case, what happens is that you put the polymer granules into a hopper, okay, feed hopper, and then it goes through the heating unit, and it melts down. Then polymer melt, we get the polymer melt, and that polymer melt is pumped through spinneret. Okay, this is called spinneret. Expanded view of that. It's kind of a lot of slits in a plate. It's a lot of slits in a plate. It's a die with multiple small holes. Okay, that through those holes, actually the polymer, due to the pumping action of this pump, polymer flows out of those holes, and molten drone region, and the air cooling is applied, and where the polymer strands get solidified, and then you can do the further treatment, like sometimes these fibers are coated with some other polymers, so that it does not they don't degrade so easily. Okay, and also you need to remove the steam. Okay, the moisture treatment, through the moisture treatment, and then it goes to the yarn driving roll. And another important thing about this process is that the final diameter wound onto the bobbin. This is called bobbin. Okay, the final reel where we actually uh, take up the fibers and store. Okay, and the final dimension of the, if you look at this one, okay, the final dimension of this is 1/10 of the extruded size. The diameter that comes out of the spinneret, okay, the diameter that comes out of the spinneret, if it is D, then the final diameter of the of each filament is D equals to D divided by 10. That means 10 times diameter is reduced during this process. How can we achieve that? When the material comes out of these slits, okay, when the material comes out of these slits, if we maintain, if the speed of this material coming out of this strip is smaller than the rolling speed of this yarn driving roll, then what will happen is that the strips will get extended. Okay, and if the strip, if for example a fiber of length this and diameter something like this, if it is extended, then its diameter will reduce. Okay, if you pull it like this way, then diameter will reduce, and that's what happens in here. The diameter that comes out of the spinneret is 10 times higher than the final diameter of the yarn, or final diameter of the fiber that we are taking up in the bobbin. Okay, and used for polyester or nylons. If you look at the nylon roofs widely available in the various shops, okay, for drying clothes, we use those nylon roofs. Okay. And the melt spinning is most important of three processes. All these three processes is very important out of these three processes, and for synthetic fibers. Okay, this is the mostly used actually the spinning method for fiber production. Okay, for the production of fiber of the plastic. Okay, do you have any question?
Sir, I have a question.
Okay.
You said that the final diameter is 1/3, which is coming out from the spinner.
1/10.
1/10. Sorry, sir.
Yes.
Is it 1/10? Sorry, sir. So why it is 1/10? Can it be any other diameter according to the requirement?
No, it is an approximate estimation. If you want to do it like 1/3 of the initial diameter, then you can do it by adjusting the speed of the driving roll. If the driving roll speed is high and the pump for a constant pumping pressure P, if it is constant, okay, for constant pumping pressure, if you increase the rotational speed of the yarn driving roll, then you will get smaller diameter here. Okay, and if you decrease the speed,
Sir,
then you get the similar kind of diameter. Okay, you can adjust that. Okay, any other?
Sir, thank you,
sir.
Okay.
What does it mean, steam conditioning? Is there any moisture addition or removal of moisture?
The steam conditioning, it can be like in case of some fibers, you need to remove the water. Okay.
Yeah.
But in some other cases, you might have to do the steaming. Okay, for the fiber longevity or fiber storage condition, there are many other parameters that can influence this kind of conditioning. It is actually moisture treatment plant. Okay, it can be steam conditioning, or you can remove the moisture if the air moisture is causes some problem with the fiber. Then you can remove the moisture, or any other treatment or whatever you want to like do it. You can do it here. Okay.
Yes, sir.
Okay, the next one is dry spinning. Okay, in the case of dry spinning, the starting polymer is a solution. Instead of melt, in the previous one, in the melt spinning, we used the polymer melt. Okay, but in this case, it's not a melt; it's a polymer solution. And what does the solution contains? It contains solvent and and the plastic. Okay, the plastic actually, in the presence of solvent, plastic actually degrades. If a polymer has a long chain, if you introduce a solvent in there, then it breaks down. Okay, it breaks down. Okay, and if it breaks down, then it acts like a solution. Okay, and that solution actually pumped through the spinner. It's same as the previous one, like melt processing or melt spinning. Same as you using a pump, you take out the polymer. That means along with the solvent, with the broken chains. Okay, and then what happens in here is that you use a heating jacket in here. That the material that comes out of the snipperette, once you heat it, that solvent actually evaporates. Okay, once the solvent is evaporated, the polymer, the broken polymer actually reconstructed. Okay, and they becomes continuous filament. Okay, and that continuous filament comes out of the heating chamber or evaporation chamber, whatever you say, the heating chamber or evaporation chamber, and then you take it up and make the spool. Okay, did you understand this process? First, you get the polymer granules, then you introduce solvent into them. Okay, then once the solvent is active, this polymers actually breaks down and they becomes like discrete particles. Okay, and they become similar to, the solution actually becomes similar to the melt that we have we discussed in the previous the melt is in the melt spinning process. And once this melt, this solution comes out of the snipperette and it is exposed to the heating zone, and due to the in the heating zone, they actually the solvent gets evaporated. Okay, once the solvent gets evaporated, the polymer is reconstructed as filament. Okay, and then you take out that filament and the filament thread, and then you make a reel with the spool. Okay, that is the process. Okay, do you have any other question?
So is there any cooling process here?
It's you don't need the cooling process in here, because it depends on the temperature, or definitely it depends on the temperature. If the evaporation temperature of the solvent is very high and the fiber is coming out here like undesirable at an undesirable temperature, then you need to apply the cooling in here. If not, it depends on the on the process, like if you what type of material you're extruding through this the fiber filament extrude dry spinning process. Okay, the fibers that are processed in here is like cellulose acetate or acrylic. Okay, okay, Pranto, did you understand?
Yes, sir.
Okay, do you have any other question? No. The next one is the wet spinning. The polymer is also in this case the polymer is also a solution. Okay, and in this case the solvent is non-volatile. In the previous case, the solvent, due to the application of heat, the solvent evaporates because they were volatile. But in this case, the solvent is not volatile. What should we do in those kind of polymers? Okay, this is the wet spinning process that we can use to extract the fibers from the plastic. Okay, to separate the polymers, the extruded must pass through the liquid chemical. In this case, the solvent is not volatile, but it can react with some chemical. If it reacts, then we can separate the non-volatile solvent from the polymer. Okay. The main purpose is that of using solvent is to make the solid plastic particles. We need to make them like liquidy. Okay, and we introduce the solvent in there in the particles so that they become liquidy. Okay, that liquidy thing we take out that liquid thing from the spinneret, and then the spinneret actually is exposed in the spin bath, where the chemical is introduced, a chemical that that actually removes the solvent. And once the solvent is removed, that the polymer again solidifies and they become like filaments. And then you take out the fibers, and then you do the stressing if you want to change the diameter. If you want to keep the diameter that comes out of the spinneret, then you don't need this stressing section. Okay. And if you need to reduce the diameter, then you can do it in here, like the spinning of this rotation of this roller should be if you want to increase the diameter, rotation of this roller should be less than the rotation of this roller. Okay, then there will be a tension force acting on the fibers, and then fiber will get extended. Okay, and then you do other further treatment like washing, if you want to wash the, if you need to wash the fibers, and then if you want to do some polishing or finishing or treatment on the surface of the polymer, or if you want to heat it, if you need to do the drying or heating any other method, then you can do it. These are the auxiliary steps. Okay, the main step is in here. The main step is the polymer particles are mixed with solvent to produce the polymer melt, and then that melt comes out of the spinneret and in a spin bath, and in the spin bath required chemical is introduced so that the solvent comes out. Okay, solvent comes out of the polymer, and polymer become a fiber. Okay, and polymer becomes solidified, and then you do the further treatment. All other treatments are optional. Okay, do you have any question in here? All right, these three processes are almost same. Okay, the only difference is the first one is the melt spinning. If we look at the melt spinning, it's just direct process using the heat to melt the polymer. In the next one, using the solvent to melt the polymer, but the solvent is volatile. It goes out with the application of heat. And the last one, we use again solvent, but solvent is non-volatile, and we remove that non-volatile solvent from the polymer using spin bath or using chemicals. And the filament produced by any of the three processes are subjected to further cold drawing. Okay, if you need to enhance the properties of the fiber, like if you want to increase the tensile strength, then you need to to realign the crystal structure. Okay, you can do the heat treatment, you can do the cold rolling of the filaments to increase the tensile strength or any other property that you want to introduce into the fiber. Okay, the raw fiber can be treated, and they can be made further processed to produce a stronger and desirable fibers using other processes. And in the case of drawing, if you want to draw it like in between the two rollers, okay, then you put the fiber between the two rollers and use another roller to pull it out. Okay, and this fiber you can use the compression of in this fiber in these rollers, and then you can use the tension in here to stress the fiber if you want to stress the fiber. So there are many other processes for enhancing the fiber properties, like surface properties or internal crystal structure or the tensile strength. There are many other processes, but we are not going into that. Okay. All right. Do you have any question so far? Because we're moving to another topic.
এই প্রসেসটা হচ্ছে স্যার মানে মূলত মনে হয় হিট ট্রিটমেন্ট প্রসেসের মতো আসলে।
Yeah, it can be heat treatment or cold rolling. Sometimes the cold rolling is used.
So what does the last line mean? Where the winding spool is driven at a faster speed than the unwinding spool.
Where the winding
spool
is driven at a faster speed than the unwinding spool.
Yes.
Okay. The winding spool is that this is the, let's say this is the winding spool. We are processing the fibers and accumulating the fibers in here. If the speed of this winding is higher compared to the feed, okay, that means there is a unwinding, the already winded spool is in here. This is already winded spool, and the fiber is coming out through these rollers. And if we increase the speed of this winding spool, then fiber will be stressed, and in between these rollers will be used for compression. Okay, and that's why at the same time they will be stressed and the crystal structure will be realigned. Okay.
Yes, sir.
Okay, the next is the plastic coating processes. The first one is that is the wire or cable coating. We have already studied that this one, right, in the previous lecture. And the second and third one we're going to study. The second one is the coating of the flat film. If we have a film and we need to coat it with some other materials, then we can do it. We can use this to coat the plastics. And another one is the contour coating, is the three-dimensional object. Let's say I have made a cup out of plastic and I want to coat it. Okay, let's say it's a plastic metallic cup and I want to coat it with the polymer. Then I can dip it into a polymer bath. Okay, into polymer bath to coat it. Okay, so this is a very simple process. And for the planar coating, we can use two methods like roll method or Dr. Blade method. Both in the case of coating, what happens is that we introduce the coating where in the coat fabrics, or let's say do you remember the leather jackets? Actually, not the artificial leather jackets. How do they produce that artificial leather jacket? They have a for example, they have a cloth and they coat it with the polystyrene plastic. Okay, that's how we get the leather jackets, which are not actually leather. Those are plastics. Okay, and for paper, laminated papers, if you want to produce a laminated paper, then the laminated cardboard, you want to protect the paper from water spillage or anything else, or metal foils. You want to coat the metal foils with the plastic, then you can do it. And the important polymers that are used in this case are like polyethylene or polypropylene with laser application of. Sometimes you can also use the nylon, PVC, or polyester. The polyester is mostly used for cloth coating of the cloth. And most of the cases, the coating is like very small thickness, like 0.01 to 0.05 millimeter. And the process are very, very small, very simple process actually. You put the base metal through the roller, and then you put the polymer on both sides of that feed base material, and then use the pressure roll. The pressure roll also act as a cooler. Okay, and then you get out the material, and then again you take up in the reel. And in the case of blade, Dr. Blade method, you introduce the polymer in here and you continuously feed the base metal, and the base metal is the polymer is separated and desired according to the desired thickness, and then you take it out and introduce the cooling in here. Okay, it's a very simple process just to apply the coating. Okay, do you have any question?
No, sir.
And in the case of contour coating, as I said, for the three-dimensional objects, once the objects are produced and you want to coat it with the plastic to prevent it from rusting or any other things or corrosion, then you can use dip it into the, or you can also use the spray technique to coat all the plastic, apply a plastic coating on the surface. Okay, dipping involves submersion of the object suitable bath of polymer and the melt or solution followed by cooling or drying. Okay, polymer melt or solution. Bath of polymer, we introduce it in the bath of polymer, and then we introduce drying method, cooling or drying method for solidification. And also we can spray paint. Most of the paints nowadays use actually polymer. Okay, they use the polymer, and the polymer when applied, they can be applied as coating to the solid object. And even the plastic coating is applied nowadays in the buildings, right? Instead of using only paint, they actually introduce the plastic coating to get the uniform structure. Okay, that's it for plastic coating process. Do you have any questions so far?
No, sir.
Okay, the next one is we're moving to a different topic now. Okay, it's injection molding. Okay, how the various parts are produced using injection molding. The best injection molding method that is used is using injection unit and coupling unit. Okay, actually today's class I will just only discuss the reciprocating screw machine, and the later we'll move to the other ones in the later. The first, if you want to understand the full process, how the thing works, we have already studied that screw injection system, right, for the continuous method. Okay,
Yes, sir.
when the polymers get continuously out within this screw. But in here, it's slightly different. It's not a continuous process. If you want to produce discrete parts, like three-dimensional discrete parts, like tiffin box or plastic bottle caps, or any other household like wardrobe or uh, cloth hangers, or dustbins. Okay, all those things, or chairs, tables, a lot of things are made using plastic, and all of these things are made actually using this injection molding method. Okay, the the function of the screw has several functions. The injection unit, that first is in the feed hopper, we introduce our required materials like polymer, along with the color, and also the plasticizer elements. If we need, how strong it should be and how ductile it should be, we can control them using this the polymer mixture. Okay, and this we put all these raw materials into the hopper, and due to the action of the screw, a motor is used for driving the screw, and due to the action of the screw, the material flows in the right direction, and there are some heaters given on top of the screw to melt the polymer, and the melting and mixing occurs in the injection unit. And another important thing, two important difference between this extrusion screw and the continuous extrusion screw that we have studied is the unit here, which is called sorry, this is not the motor is in here. Actually, using the gear system motor works, and this one actually is a pneumatic, either pneumatic or hydraulic system, screw ram. And the function of this is that to push the screw rightward or bring it back. Okay, you can using this ram, you can push the screw at the front side, in the front side, or and you can take it back. Okay, this is one of the function of the difference from the continuous extrusion screw. In the case of continuous extrusion screw, there is no such function, because the polymers are continuously getting out. In this case, polymers are not continuously getting out. After some time, polymers are pushed into the cavity, and then you take the screw back. Okay, and the screw rotation is not only in the forward direction. Okay, uh, it goes to the forward, and also it goes to the backward. And there is another important difference from the continuous screw that we have studied previously, is that this non-return valve. Can you remember any non-return valve? That means the flow is only unidirectional.
No, sir.
Pranto,
There
I think
is
you
nothing like
have done a lot of work with that, with this non-return valve. I don't think I believe. Okay,
yes, sir.
in our CRTs, which one?
Yes,
Tube oil. There is a valve in the tube oil, right?
yes,
We call it like check valve,
sir.
right?
Yes, sir.
Yes,
Yes, sir.
that's a non-return valve. You
Yes,
take the water out of the pipe and then it closes. Water doesn't go back. It is just only one direction. Okay, unless there is a leak, right? So this valve actually acts as a non-return valve. That means polymer can only pass in the forward direction, and the polymer cannot go back in this direction. It's not possible to go back. It's non-return valve, which was not there in the case of continuous extrusion method. And this actually, and there is a nozzle to get the polymers out, and this unit is called clamping unit. In this case, we utilize a die, or sorry, a mold. Okay, a mold has a cavity. This is the
So
cavity.
there exists another difference in the injection unit.
Which one?
I think. I think it
I can't hear you. Pranto, can you hear me? Can anybody hear me?
জি স্যার
হ্যাঁ স্যার
Yes,
শোনা
sir.
যাচ্ছে
Oh,
স্যার শোনা যায়
Pranto is disconnected.
Sir, I
Alright.
have a question.
Yes, of course. Go ahead.
Sir, is if it is sorry sir, I know the continuous screw system, sir.
Okay.
Last class maybe, but
Yes.
here why reciprocating needed? If a screw machine is enough for to push the material, but
Okay.
why
Yes, I
reciprocating
understood your
twice is
question.
needed here?
In the continuous type screw, you take the material out of the nozzle or continuously, right?
Continuously,
But in
right?
this case, you don't do that. Once a part is formed and cooled, you need to take that part out, and then another stock of material should come into the mold. So it's a discrete process. That's why you need to push the screw to push the polymer out. And the function of the screw is only to drive the polymer from to transport the polymer material, and to take the material out, the function the screw ramp comes into play. Okay, it's a discrete
sir.
process. All right.
so in that case the screw was gradually increasing, but
In this case also, the screw is gradually increasing. Actually, this figure does not show the thickness. Okay, but in this case also, you need to use that, because if you don't do that, there will be a lot of pores
yes sir,
because of the initial material. And there is also another thing we need to remember, is that how do we remove those air from the material? Even if we compress, air is not going to come out.
yes sir.
And that is why we need to provide, in some places you need to provide some vents, okay, which are not shown in here. You need to
Yes.
provide some vents, and at the same time you also need to provide vents in the die. I'll come to that later. All right.
Yes.
Okay. Now we come to the do you have any other question? Anybody else? How many persons in here today? Only 9. Okay. All right. So in the clamping unit, what do we have in the clamping unit? First, there's a clamping cylinder which is used to separate the mold. There is a mold. What is the mold? Mold contains a cavity of the product that you want to make. Okay. For example, if you want to make a cup, then this mold will contain a cavity which produces a cup. Okay, there will be empty spaces where polymers will come and get solidified, and then you take that out. Okay, that's what the function of the mold. And the mold has 2 platen. One is fixed. This side, this one, I'm doing the red line. This one is fixed. Okay, this one is fixed platen, that is called a stationary platen. And other one, I'll use a different color. I think use a different color. Let's say green. And this one, okay, this one is the moving platen, movable platen. Okay, and what is the function of this hydraulic cylinder? The function of this hydraulic cylinder, clamping cylinder, is that to move the movable platen. If you want to move the movable platen on the right, then it goes right. And then if you want to put it to if you want to remove the material after solidification from the cavity, then you move it to the right and then take the material out. Okay, and if you want to close the cavity again to get another stroke of material, then you use the other direction. Okay, and these are the tie rods. These are actually guides. Okay, the movable platen actually moves through these two, this guide and this guide. Okay, and we'll see the whole process actually step by step. Okay, in the next slide. The first step of the extrusion injection molding process is that to prepare the cavity. The material is ready. Okay, the material is ready in the injection screw, and the cavity, to produce the cavity, you move the movable platen and produce the cavity, so that material once poured into the cavity does not get out. Okay, if you don't attach them together, the stationary platen and the movable platen, you attach them together so that the cavity is blocked and it is ready to get the material. And how do we get the material? We move the screw. Okay, the screw ram that we have used, okay, the screw ram, we use that screw to move forward, and that non-return valve comes into play. The material that is already in this location, that cannot go on the backward. So there will be a pressure created in this region, and due to the pressure, the material, the polymer will get into the mold, and the polymer, the cavity will be filled. The cavity will be filled with the polymer melt, and then we give it certain time for cooling. And for cooling, we use the coolant will be passed. There will be some holes in the mold. Okay, in the movable or fixed die, there will be some holes through where we provide the cold water for cooling purpose. Once the material is cooled, then we do the solidification. The third step is the solidification step, and during this time, during the solidification stage, the screw moves backward. Okay, the screw moves backward. It rotates and moves backward, so that the further material comes into this place. Otherwise, what will happen if we don't rotate the screw and only we move it backward? Then there will be, the material will there will be air gap, right?
Yes, sir.
There will be air gap, or there will be a negative pressure created in the region, and that is why if we rotate the screw and push it backward, then the material in this side will come in here and fill it up. Okay, and that's what happens in this case. Once the injection is complete, we start cooling, and at the same time the screw goes backward to release the pressure in here. Then the pressure will be environment pressure. Okay, and once the pressure is attained, then we move the movable platen outside and then take out the material. And due to the environmental pressure is raised in here, there is only environmental pressure, there is no excess pressure. The material is not coming out in this way. Okay, material is not coming out, it's just staying in there unless we start pushing again. Okay, so it is a discrete process. Once a part is made, we take the part out, and then we close the cavity again, and then we get another stock of material, and then we get another stock of material. It's a discrete process. But the total time required for producing a part depends on the size of the part, as well as the cooling method that you are using. And also, even if you need a lot of material in here, even if this part size is higher, the process does not actually require more than 30 seconds. Okay, it's like less than 30 seconds you produce a part. Okay, do you have any question? I think to get better understanding, you can do some YouTube search using the injection molding processes. Then you'll be able to see a lot of real-time videos, and also the animated videos. Animated videos are really good for understanding these processes. Okay. Okay, I'll get the questions. Do you have any question?
Okay, sir. Thank you.
All right. And I think we'll start on this two-plate mode in the next class, which will be on Thursday, right? Next Thursday at 7:30. And tomorrow there will be a presentation. And who is going to give the presentation?